Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, the periodic table. Today we will begin with lecture 6 from the course, but make sure you have watched the previous ones before viewing this one. In the last few lectures, we have been discussing quite a lot about the periodic table, and I hope that all information is clear to you. Today we are going to put into use all that information, and then this lecture is going to be a really interesting one because with that information we are going to predict the period and the groups of elements when the atomic number is given to us. And having learned how to do that, we will do some numericals based on the concept. So let us begin this beautiful lecture of ours. So in order to predict the group, the period and the block of an element, what is required? Well, you all know that the periodic table, this is based on the increasing atomic numbers. That means there is a relation to the periodic table and the electronic configuration, the atomic number being equal to the number of electrons in a neutral atom. So all that you require here to predict the period, the group, the block of an element is the knowledge of the electronic configuration. If you know how to write the electronic configuration for an element, then the things are really simple for you. Let me explain you how. We will start first of all with the period. To know the period of an element, the period is going to correspond to the principal quantum number of the valence shell. That means that you have to write the electronic configuration of the element, and then wherever is the electron going into the last energy level, that is going to be the period of that element. For example, we have sodium with the atomic number 11. The electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. So what is the valence shell configuration? Yes, it is 3s1. So 3 is denoting the principal quantum number of the valence shell, and therefore this is going to be the period of sodium. So sodium belongs to third period. Now what about the block of an element? Well, the block is predicted on the basis of the valence orbital that receives the last electron. We have devoted a whole lecture, I think, to the understanding of the blocks of various elements. So this is not going to be difficult for you. So again, the example of sodium, the valence shell configuration is 3s1. That means the electron, last one, is entering into the s orbital. So the block for sodium is going to be s block. So now coming on to the most interesting of them all, that is prediction of the group. The group is predicted from the number of electrons in the valence shell, and also maybe it dependent upon the penultimate shell n-1 electrons. How? Let me explain you. So we have the last electron when it is entering into the s subshell. The number of the group, this is going to be simply equal to the number of valence electrons. If the valence electron is 1, it is going to be group 1, and when the valence electrons are 2, it is going to be group number 2. Then we are coming up to the last electron in the p subshell. Here the group number, this is going to be equal to 2 plus 10 plus number of valence p electrons, right? So this 2, do you know why this has come from? This has come from the filling of the s orbital, and then the 10 for the filling of the d orbital. And these are filling before the p electrons as far as you understand the periodic table, right? So we are going to simply add 12 to the number of valence p electron to get the group of the p block elements. Fine. Next we have the d block elements. So the last electron is entering into the d subshell, and the number of the group, this is going to be equal to 2 plus number of n-1 d electrons, right? I think now this is clear. Now what about the F subshell filling. There has to be something for that also. Now, if you remember the positioning in the periodic table, while we were discussing the F block elements, they were the lanthanides and the actinides. Lanthanides, they were occupying the same position as lanthanum in the periodic table, that is group number 3 and period number 6, right? So the elements from 58 to 71, that are 14 in number, the F block elements, they occupy group number 3 along with lanthanum. Similarly, we have actinium and the actinoids occupying the same position in group number 3 and period number 7. So always remember that when the last electron this enters into the F subshell, the group number is always going to be 3, right? I think this is going to be very important for you. Otherwise, you're going to get confused in the configuration when the last electron enters into the F subshell. Now, let us understand all this with a few examples. So we have sodium again with the electronic configuration you all know. The valence shell you can see over here. So we have 3. 3 was what? It was the principal quantum number which was giving us the period of sodium metal. And then we have this S. So S means the S block, right? And then we have 1. 1 is going to give the number of valence electrons, and hence the group is going to be 1 for sodium. So period number 3, group number 1 and S block for sodium. Everything fitting fine now? Now let us see a few more examples for the other groups as well. So we have atomic number 43. Let us write the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d5. Right? So now what all do we have to see? First of all, we have to see which is the highest energy level that is being occupied. So the principal quantum number over here is 5 maximum. So this means that the period for this is going to be the 5th period, right? Then we have to see the block. So what is the block for this? Well, the last electron, if you will see, this is going into the D subshell, because the D subshell of the penultimate level, this is not filled, right? 5s2 is filled, but 4d is not filled. So this means the last electron is entering into the D subshell, and hence this is a D block element, right? And then how are we going to predict for this D block? We are simply going to add 2 to the number of D electrons. So the group number is going to be 2 plus 5, that is 7, right? I think now it is fine with you. Okay, let us see another example. We have Z equal to 115. You will write the electronic configuration for this. This is long and I think you can write it out yourself. So I will be just focusing on again the last shells. So we have 7p3 over here, and you can see before the filling of the p electrons, the inner shells, they are always complete. Okay, so you can see that 5f14 is done. We have 6d10. So the antepenultimate shell is also complete. The penultimate shell is also complete before there is the filling of the p electrons. So now what do we have to do? We have to simply tell the period is going to be 7. The block is going to be p, because the last electron enters into the p orbitals, and the group is going to be what? 2 plus 10 plus 3 for the 3 electrons in the p valence shell, right? So p orbitals. So this is going to be 12 plus 3, that is 15. Okay, I think it is clear. Now last one for you as an example, Z equal to 64. Write out the electronic configuration, which I all know you're going to do that very well. So again the last shells that I am going to see is 6s2. This is the highest energy level that is being filled. But before that, I can see that there is 5d1 also and 4s7 also, which are not completely filled. Okay. So whenever you see only the highest energy shell having s orbitals being filled, please do check the penultimate and the antepenultimate shells also. If they are incomplete, this is not a s block element. Okay, so 5d1 and 4f7, this shows that the filling is going into the f subshell. After the F, there is going to be the filling of the 5D, and then we will continue with the 6P. Fine. Therefore, the period for this is going to be 6 for the highest energy level. Then electron into the F subshell. So we have block F, and the group for the F block elements is always going to be 3. So we have this as the third group. Okay, I think everything now is clear to you. So now let us do a few numericals based on these, and I think if all the concept is clear to you, you will be able to do these questions quickly yourself. So I would request you all that as you see the question, just pause the lecture and then do the question yourself before we discuss it between us, right? So the first question we have is the electronic configuration of some elements. They are given below. Group these elements which you expect should have similar chemical properties. So these are the 6 electronic configurations that I have for the 6 elements. Let us see what are the similar chemical properties having elements. So if you are done with your answer, let us see the solution to this. Well, the similar chemical properties are going to be for what elements? The elements which have similar electronic configuration. So here you can see A having the outer valence shell as 3s1 and D having 4s1. So that means in the valence shell they have just one electron each, and therefore they are going to have similar chemical properties. A and D being similar. Then we have B and E. If you see B and E, so B is having 2p6 and 3 is also having 3p6. So this means that the outermost shell having 2s2 and 2p6, this is also fully filled, and E 3s2, 3p6 again fully filled. This is a noble gas configuration. B and E both are inert gases and hence they have similar properties. Next we have is C and F. So this is 3s2 and 3p5. And F is 4s2 and 4p5. So here both of them, they are having 7 valence electrons, and that means they both are halogens and hence they are having similar chemical properties. The crux of the question, to have similar properties, the elements must have similar valence shell configuration. So the second question I have for you is that the outer electronic configuration of atoms of some elements, they are given below, and we have to tell in which group and period of the periodic table they are situated. And having done that discussion, I think this is going to be very simple for you. For the first one, that is 3d0 and 4s1. So this means that the inner shells, they are already complete. The d orbital filling has not yet started, right? So that is what you are most importantly to see, that whether the penultimate d subshell is filled or not. Okay, so if it is partially filled, that means the electrons, they are entering into the d subshell, and this is going to be a d block element. Fine. So now it is 0 over here. So this means that the electrons are being filled into 4s orbitals, right? So the highest shell we have is 4. That means the period for this element is going to be 4. The s block element, because the last electron enters into the s orbital, and this is only one electron in the valence shell. So this means this is group 1, that is the alkali metals, and according to Mendeleev, this is going to be group 1A. Fine. Next we have is 3s2, 3p5. So this over here is going to be what? So this means that the highest shell configuration is 3. So this means that this belongs to period number 3. Then the last electron being filled into the p orbital. So that means what? It is going to be a p block element. And now the p shell electron, p subshell electrons, they are 5 in number. Simply add 12 to that. You will get group number 17 or 7a as far as Mendeleev's periodic table is concerned. Right? You should know the Mendeleev's periodic table classification also of the groups, because sometimes this is given in the question and then you may not be knowing and not getting the marks which you should have got. Right? So now the next one we have is 4s2 4p6. So here also what is going to be there? The highest shell in the configuration is 4. So this is going to be the period 4. And then we have the last electron entering into the p subshell. So this means it is a p block element. And then it is going to be 6 plus 12. This means 18th group. That is the 0 group of Mendeleev, and these are the noble gases. Then we have the D. Here we have as 3d8 and 4s2. So that means that the D subshell is partially filled. The last electron is entering into the D subshell. So this is going to be D block. The highest shell configuration, that is 4. So the period is going to be 4. And the group is going to be 8 plus 2. That means this is going to be 10th group. And that means this is going to be column number 3 of the 8th group of Mendeleev, right? So the 8th group of Mendeleev starts from 8, 9 and 10, the 3 columns of his, which were his subgroups. So that means that this is 8th group and 3rd column, or from the modern periodic table, it is group number 10. I hope this thing now is clear. This will be perfect with you people. There should be no marked deduction over here. So next we have to find the number of period, group and block in which the element with atomic number 24 is present, and this one is important for you to understand. You have been doing the electronic configuration for this element in the structure of atom. This is chromium, if you remember, and this is even important here also. Why? Let me explain this to you. The electronic configuration of chromium with the atomic number 24 is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Right? So from here, the highest shell present in the electron configuration is 4s. So that means the period number is 4. Fine. The last electron, this is going into the D subshell. You can see that it is 3d5. Therefore, the element belongs to D block. And the group number is 6. Wait, why is it so? That is what you are supposed to understand. Right? We are saying that this is 3d5, and for the group number I told you, you just simply add 2 over here to the T. So this means that the group number should have been 7, but I am telling you that it is group number 6 because actually the configuration should have been 3d4, 4s2. It is only to have a partially filled orbitals that are more stable, that the electrons, they jump from one orbital to another, right? So that is why we have 3d5 and 4s1. But if we want to predict the group, just write it simply the way it should have been else otherwise, and you will get this as 4 plus 2 and group number 6. Fine. I hope this is clear, that you will not add as 2 to the 5, but you will add 4 plus 2 over here. I hope this is clear. This is very important. Children do make a mistake over here while writing the group number. Now, the next question we have is write the electronic configuration of the element with atomic number 3, 10, 16, 17 and 24. Which of these is an inert gas, a chalcogen, an alkali metal, a halogen, a transition element? and write the name of the element and the block to which the element belongs. So let us begin with writing the electronic configuration for the first one. So we have atomic number 3. That means 1s2, 2s1. So now I think you would be able to tell everything about this. 2 means the period is 2. S means that the block is S. And 1 valence electron, this means this is group 1. Group 1 is nothing but alkali metals, right? So I think, and the name of the element is lithium. I would request you all to remember the name of all the first 30 elements, okay? That is going to be really very important, and it would be great if you could remember whole of the S block and the P block elements atomic numbers as well, but still at least till 30 you must. Then we have atomic number 10, which is 1s2, 2s2, 2p6. So again, I think you will be able to tell 2 is going to be the period. P, so this means P block element, and because it is 2s2, 2p6 filling of the second shell, this is an inert gas and the gas is neon. Then we have 16, so this is going to be filling electronic configuration as 3s2, 3p2x, 3py1 and 3pz1. So here this is third period P block element, and then we have 4p subshell electrons. So this means 12 plus 4, that means 16th group. 16th group is oxygen family or the chalcogens, and the element is going to be sulfur. Next we have the atomic number 17 just next to sulfur, that is going to be chlorine. If you know the periodic table very well, but otherwise if you do not, you will be able to understand this is the third period, then P block element, and then there are 5 electrons over here. So 5 plus 12, that is going to be 17th group, and 17th group is halogens, right? And this is going to be chlorine as well. Now we have atomic number 24 coming up again, and we have discussed about this in the last question, so I do not need to discuss that further, except that the D block elements, they are called as transition elements. This is going to be the last question for today. So these are the 3 elements A, B and C having atomic number Z, Z plus 2 and Z plus 3 respectively. Among these, C is an alkali metal, and to which group of the periodic table do elements A and B belong? So we have the atomic number of C, that is an alkali metal, to be Z plus 3. So this means that this is present in group number 1, right? So if we have A with the atomic number Z, this is going to be 3 less groups from number 1. So that means we are going to go back from 18 to 17 to 16th group, right? So the atomic number Z element, this is going to be in group number 16 or group number 6A, and these are the chalcogens. Next we are going to have B, and B has atomic number Z plus 2. So either you can add 2 to 16 and make it the 18th group, or you can go back 1 from alkali metal and again you will end up to the 18th group. So this is going to be group 0 or 18, which is the noble gases. I hope this is clear. So that would be all for this lecture. I hope everything is very clear. I have tried my level best to explain you. There are many questions asked from this topic, so I hope you will be able to do that perfectly well. In the next lecture, we would be discussing a very important topic, that is screening effect. So I hope you will join me for lecture number 7. Till then, if you have any difficulty, you can mail me at h2ochemistry@gmail.com, and then you can please subscribe to the channel H2O and click on the bell icon to get a notification as and when I put up a new lecture for you, a new course for you. And if you've liked the lecture, please do click on the like link as well. Thank you. Have a nice day. See you again for lecture number 7. Bye bye.